Hey everyone, welcome to the Chemical Reaction Notes with Mr. Biter, me. A chemical change is also known as a chemical reaction, and this is one of the most interesting topics in chemistry usually. Chemical reactions are all around you. Life itself would not be possible without chemical reactions. You would not be possible without chemical reactions. So let's get into these and see how chemical reactions actually work. Chemical reactions involve making new substances. New compounds or molecules are formed from previous compounds or molecules or atoms. And those chemicals that are at the beginning are also there at the end. And a chemical reaction involves the breaking or forming of chemical bonds. Let's take a look at this. So this is a chemical equation, and we have one side, the left side, has the reactants, and the right side has the products. In this case, we're taking hydrogen and oxygen, and we're combining them together and synthesizing a product called water. Let's take a look at this and talk about what's happening. So here we can see I have a model of each of these. I have some oxygen here represented with these yellow rectangular cuboidal solids, and I have also these wooden round ones here that will represent our hydrogen. All right, notice we have two molecules of the hydrogen molecule and only one of the oxygen. Now if we break these apart and we rearrange the chemical bonds, we can get water. And this is where we have the chemical reaction occurring. Now, note that we do not have anything new coming into this. We have the same stuff at the beginning as we do at the end. All right, I got one made here, as you can see, and then we just make one more model, and we get two water molecules where once there was only hydrogen and oxygen. But we have the same number of atoms both before and after in this case. We have 4 hydrogen at the beginning, and we have 4 hydrogen at the end. We have 2 oxygen at the beginning, we got 2 oxygen at the end. So we have a chemical reaction, right? The atoms are just rearranged. Now, what evidence shows us that a chemical reaction might actually be taking place? Well, there's 4 things we look for when trying to observe chemical reactions: bubbling, temperature change, color change, and whether a precipitate is formed. Now you can see a precipitate in this drawing at the bottom. Yellow solid is being made after 2 liquids are put together. You will also be familiar with bubbling. If you ever mixed baking soda and vinegar together, you get a bubbling. Now here's a picture of you put aluminum and hydrochloric acid, you end up getting some bubbles produced. That bubbling is evidence of a chemical change or a chemical reaction. Sometimes there's a change in temperature. Fire is a chemical reaction. It's getting hot. That is evidence of a chemical change. Cold packs work the same way. You break that thing in the middle, you mix it up, and you get it becomes cold. That is a chemical reaction. So all these types of evidence of chemical reactions often are not isolated. Usually you get more than one piece of evidence to show that a chemical reaction is occurring. Now, how can we make chemical reactions go faster? Like, how could we make this hydrochloric react faster with the aluminum for more bubbling to make that go faster? Well, one thing we could do was we could increase the temperature. We could increase the temperature. We could also break up that piece of aluminum into smaller pieces. That'll increase the surface area. We could also make it a stronger acid. make it a higher concentration of acid. We could also maybe add a catalyst. A catalyst is a substance that you can put into a chemical reaction, and it won't be consumed in the reaction. It'll just make it go faster. This is how a lot of the chemical reactions in our body occur. We have chemical reactions that are aided by enzymes, right? Enzymes are special catalysts in our bodies. Lastly, we need to talk about the law of conservation of mass. Matter cannot be created or destroyed. So in the chemical reaction, you have the same amount of stuff at the beginning as you have at the end. Same thing with our example with these. We have the same number of atoms at the beginning as we had at the end. They didn't change, they were just rearranged. So we end up having the same mass at the beginning and at the end. It's equal. So in this chemical equation, we have equal quantities at the beginning and at the end, just like indicated in this example. So use this knowledge to help you find evidence of chemical reactions around you and think about how the world works.